Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And holy smokes, did it take longer to produce this than I thought it would. An awful lot of numbers and crunching and all that sort of stuff. But I think in the end, I came up with a fairly basic graphic, at least I hope you see it as basic, that will help me to make my point. But you know that I've been talking ad nauseum over the last several weeks about the advantages of using ensembles versus deterministic models, especially when you're looking at something out in time. The basic idea behind ensembles is that we cannot observe the atmosphere perfectly, and so any analysis of any weather model is flawed right from the start. Now, it's not flawed greatly, but it is flawed, and those errors are going to multiply and grow with time. So by perturbing or changing the initial conditions to 30 different extents, and in the case of the European, 50 different extents, then you, in a sense, are trying to account for those small errors in the analysis, okay? That one of those changed analyses, if you will, could end up being a better one than the one that the deterministic model is actually using. So if you run all of these models with slightly different initial conditions and all the solutions are fairly similar out in time, then that gives you pretty high confidence in the forecast. But if they diverge wildly, then you don't. And a lot of times that is the case as you go out to a week and beyond. So what I did was I went back and looked at every run of the American model and the American model ensemble group going back to 7 o'clock on Monday morning, and they run these models every 6 hours. So you had 7 a.m. Monday, 1 p.m. Monday, 7 p.m. Monday, and then you have 4 on Tuesday, 4 on Wednesday, 4 on Thursday, 4 on Friday. Actually, I only went up through 7 a.m., so 2 on Friday. So what is that? You've got 3, and then 4 is 7, 4 is 11, 4 is 15, and 2 more. That's 17 model runs, okay? And I went back and looked at the forecast high temperature for the Raleigh-Durham Airport, the ensemble mean, and the deterministic model forecast, and this is what I came up with. Now, you're not going to be able to read any of these numbers here, okay? I'm simply showing you what I did. These are all of the high temperature forecasts from all the model runs, and up in the upper left you might be able to see that it says Monday at 7 a.m. and then every 6 hours on through Friday this morning at 7 a.m. And the forecast, what I started with, was Friday. So that would be a 4.5 day forecast from this past Monday, okay? By 4.5, you're starting at 7 o'clock Monday morning, and the high temperature isn't observed officially until 7 o'clock on Friday night. So that's a 108-hour forecast, or 4.5 days. And then what I did was I took a look at all those runs to see, okay, for all the runs verifying today, for the high temperature today, how did that forecast high change as we went through the week, okay? And how much did it vary, okay? So here, I've highlighted all of the deterministic model forecasts, and I've highlighted in blue the lowest reading, the lowest forecast high temperature for each one of those days, starting today and going all the way out to Tuesday of the following week, which is like, you know, more than 2 weeks out. And then the next one here, I highlighted all of the ensemble forecasts and the highs and lows that it had for, in other words, the high and the low forecast for the high temperature. I know it's confusing. And see how much variance there was. So here is the graphic when it's all said and done that I came up with, and I'll try to make this as clear as I can. So along the x-axis there, you see it says 4.5 to 0.5. What that means is we started off Monday with a 4.5 day forecast verifying tonight, this evening. And then I took a look at every model run as we got 6 hours closer to time, okay? And went to see, or tried to see how much variance there was in those forecasts as we went through each one of those model runs every 6 hours, ending with the one this morning. So for the first 3 sets of bars there really isn't that much difference, okay? Like the third set of bars is a 6.5 day forecast going on down to 2.5 days, okay? And that would actually verify on Sunday. So some of this hasn't even happened yet, okay? But that's not the point I'm trying to make. The point I'm trying to make is how much variance there is in these forecasts as you go on through time with all the model runs. Now, once we get to the 4 set of bars, which would be a 3.5 to a 7.5 day forecast, okay, which would actually verify this coming Monday evening, okay? Look at the difference now. The ensemble mean had a range of 8 degrees, so its forecast high temperatures through all the model runs for next Monday only had a variance of 8 degrees, and the deterministic model had a range of 17. It gets worse. The next day, verifying Tuesday, the ensemble had a range of 10, the deterministic 25. Then it comes down a little bit to 5 and 19, and then it just explodes, 8 and 28, okay? So the ensemble mean range was 8 degrees through all the forecast runs, or all the model runs, and the deterministic range was 28. And by the time you get out to around 2 weeks, it was 30 and 28 and 31, and yet the ensemble mean just sort of hung out there between 6 and 7 for the last 4 verification periods. So again, and if you think this is bad, how do you think it's going to handle forecasting the precipitation type a week and a half out, okay? And I look with horror, absolute horror, when I go on YouTube and I see people showing a 384-hour deterministic forecast. That's 16 days. And then they'll try to dissociate themselves from it by saying, oh, but that's not what I'm forecasting. I'm just sharing it with you. No, you showed it because it showed something exciting and you wanted to get eyeballs. That's why you showed it, okay? And so the point here is that until you get close to the actual event taking place, then you have to be extremely careful, and in my opinion is just throw it out and use the ensemble mean and look at the variance in the different ensemble members. And then once you get within, 3 or 4 days, then you can start taking the deterministic model a little bit more seriously, but certainly not until then. And so I hope this graph shows that very, very clearly. It's just unbelievable the run-to-run jumps that took place over the past 4 days, verifying, at different periods of time out into the future. But, when you're knee-jerking 30 and 31 degrees between model runs, that's pretty bad. All right, that's it for now, folks. I hope you all have a wonderful rest of your Friday evening, what's left of it, and if you even see this tonight. And if you see it tomorrow, then I hope your weekend is going well and the rest of it goes well as well. Okay, you all take care. We'll talk to you again on Monday. See you later, everybody.